All right, this is chapter 8. We're going to try to get through this a little faster. I may do some of these things different than your teacher. Apologize if that's the way. But I don't have time to work it every single way. So let's look at these. Let's start with AC. So number 8A, I got AC, which is the whole length of the large triangle, to ST, which is the whole length of the small triangle. Okay? So I'm going to be talking about parts and wholes, okay? And I may talk about triangle A, triangle B, or the large triangle and the small triangle, whichever way it's just easiest to figure it out for that one. So CT is only part of a side. It's not the full side of any triangle. It's part of a side in the large triangle. And TR, let me do a different color here. You could say it's part of a side in the large triangle, or you could say it's the whole side in the small triangle. That's probably the better way. Part of a side of the long triangle works, but we'd rather do the whole side of the small triangle. Either way, we can set this up. So let's take a look at this. If I've got the whole side of a large triangle to the whole side of a small triangle equals the partial of the large to the whole of the small. Well, one thing we learned is that whenever we do these, we need to make sure that things line up. It's like a Punnett Square. When you're working this, it's like a Punnett Square. What you need to do is make sure that you've got things in this column, row, and this row the same. Well, here I've got S. It's almost like factoring. I've got an S the same, and here I've got an L the same. Okay, that's great. Here I've got a W the same, but here I don't really have anything the same. I got P and W and L and S. So this does not look like it's set up to go. So let's just get rid of all that and say that no. This is not going to work because this is whole to whole equals part to whole, which is not really what we wanted. Okay, so 8B. AS is a partial length in the large triangle, okay? SR is a whole length in the small triangle, and that's not necessarily bad. We can do that. CT is also a partial of a large triangle, and TR is the whole side of the small triangle. So do they correspond? Let's start with that. Yes, this is red. The two red ones are from the same corresponding locations. The two blue ones are from the same corresponding locations. Okay, and if I set this up, what I get is part of the large to whole of the small equals partial of the large to the whole of the small. Let's look at our Punnett Square. Does it work? Does it work? Well, yeah, I've got P in common this way. I've also got large in common this way. I've got these are wholes. Okay, that's good. These are in common. What's in common this direction? Well, they are from the same corresponding side. So they correspond. Okay. And these also correspond. These are both from the large triangle. That's good. These are both from the small triangle. So what we end up having is we've got two from the same triangle lined up, two from the other triangle lined up, and these are the corresponding parts, okay? Partial of that side to the whole of that side, partial of that side to the whole of that side. This looks good. We can do this one. So yes, this is true, and this is false. All right, so let's do it again. And I'm probably not going to draw it all out as much this time. Now we're just going to kind of look at it. So SR is the whole length of a small triangle. AR is also a whole, so whole is the whole. Whole is the whole. ST is a whole. That's good. And AC is a whole. Now, the only question is, do those correspond to each other? Do ST and AC correspond to each other? Yeah, they're the similar shape. They're this bottom side on each triangle. Do SR and AR correspond? Yeah, they're both this left-hand side on the same triangle. So I would say these correspond. We've got whole is to whole is whole is to whole. This looks like a classic case. This is true. Okay. So this one was true. And then finally, let's look at AS. AS, which is a part, to SR, which is a whole. Okay, SR is a whole. And then AC, which is a whole, to ST, which is a whole. I'm already seeing something I'm worried about. Look, whole and whole, a whole and part. Okay, that's probably not going to work. I think what we would have needed was for this to be a R, okay, so that I could have gotten the whole length here, and that would have been good. But that's not going to work. We're going to end up having part is to whole as whole is to whole. This is definitely not lining up and looking right, so this is false. Okay, number 8E. So I'm just going to look at this thing real quick before I even talk about anything else, and I'm going to say, gosh, that's vertical angles. I got to have that marked in there. First thing I see, I love it. So ABE is similar to ACD, so they already gave us to it. It's like, Mr. Conaway, great, you're already wasting time. They already told us ABE and ACD are similar. So I know they're similar, okay? And I know that A lines up with A, B lines up with C, and E lines up with D. So I can go ahead and say, look, this one has to line up with that one. And this one has to line up with that one. And I also know that this is 15, and AD is 18, and BE equals 10. Find AE. So I'm going to call that X. Okay, well, that looks perfect because just by looking at the way it's lined up, 15 is the side that connects from the 2 marker to the 3 marker. Well, you know what? So is 10. Perfect. Those two line up with each other. So I can say 10 and 15 match. Well, 18 corresponds with the connection between the 1 and the 2. Well, so does the RX. So we're good there as well. Now, you have the option of how to set this up. There are 8 ways to set this thing up right. There's about 16 ways to set it up wrong. But let's start with the best way to set it up right, in my opinion. Now, it's not the only way you can set it up, but I always start with the unknown in the top left-hand corner. Because if I put it there, it's a little easier to solve if there's only one unknown. So X, and I can choose where to go now, because there's 8 ways to set this up. Just whatever you feel you like better. I personally usually will set up and say, look, I know the X matches with the 18 because they kind of mark off the same sides, the corresponding sides. So X is to 18 as, now X was from the small triangle, so whatever goes over here has to also be from the small triangle on the top and the larger one in the bottom. Okay, so from the small triangle, I'm going to go with the 10 and the 15 from the big triangle. And then this is just simple cross multiply and solve. Always save yourself a little time. Reduce, cross multiply. And remember, you don't always have to cross both crosses. Just because somebody says you do, they don't. Math works different ways, guys. This can just be crossed once. Basically, you know, and cross multiplying is just a lie anyways. It's not really there. It's this. That's all we're doing. We're multiplying both sides by 18. And we call it something called cross multiplication. I'm going to reduce 3 with 18 and get 6. And then that leaves 2 times 6 equals 12. So X equals 12. X also happens to be AE. So we're good. We don't have to go on any farther. You could say x equals 12, but it's multiple choice, so you'd probably be fine. I would probably replace that with AE on an open response. Okay, Marisol is making a scale model of the Great Pyramids for history class. The real pyramid's 220 feet tall and 170 feet on a side. All right, let's go back to our Punnett Square idea, guys. Basically, we just want to make sure that things line up here, 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 and here. Okay, so I could say, if I want to do this, I'm going to say, look, this is the real on top, and this is the model on bottom, okay? And I'm just, there's probably a better way to line this up, but I'm just giving you guys one example here. So this is going to be how tall, and this will be how, what are they calling it, on a side. So how wide it is on side. Okay, wide on side. So if I go and just fill this in now, the real one was 220 feet tall. The model one was, well, we don't know. So we better use an X or a T. Why not a T? Why not a T? Come on, Mr. Conaway. Get away from that X. All right, and then the other one, the real one was 175 feet on a side. And how tall? Oh, well, her model was 9 inches on a side. Okay, so we probably want to keep our units in here. We got feet, and inches. So let's cross multiply and solve. Or as you've gotten better with your cross multiplication, hopefully by now you realize that you can do some tricks like swapping these two. And then I'm just going to multiply both sides by 9. Okay, so that's going to multiply up there. So I'm going to end up getting 220 feet, the 9 inches, over, since I swapped these two, the 175 feet. And that's going to be equal to T. That's a little bit of crazy math, Mr. Conaway. Where are you coming up with this stuff? Well, the feet over the feet are going to reduce to 1, and then I'm going to cancel out, and I know a 5 can go into those, but I'm just going to ask for my trusty calculator here to say 220 times 9 divided by 175. 392 over 35. And the only unit that's left is inches. So it's 392 over 35 inches. 396 over 35? And could you give us that approximately? In case your teacher likes you to round. 11.3 inches. Now, it's actually good to round because rounding lets us estimate and see if we're right. The real one was 220 tall and 170 feet wide. So it's a little taller than it is wide. Well, the model was 11.3 tall and 9 inches wide. I'm not seeing anything to get alarmed about there. It's a little taller than it is wide. It's a little harder to estimate 396 over 35. But 11.3 we like. We're used to it. Okay. What is the scale factor of ABC, triangle ABC to triangle MON? Hey. So this is probably where we're going to get into some differences between what the question is asking for scale factor. So of ABC to MON. So this is the small and this is a large. So that means that we are doing an enlargement. And if it's an enlargement, then we know that K has to be greater than 1. K has to be greater than 1. So that we're going to use just to check this when we're done. So what I can say is, listen, there has got to be some number that I can multiply to get from the small triangle to the large triangle. So let's match up. Over here I have 24 is ON. ON matches with BC. So that means I'm going from 14 up to 24. Now, it's important that you match it up. You notice they gave you an extra number here. You don't need the 12. It doesn't come to play in this problem. It's there as a distractor. And it looks so nice. 12 goes to twice to be 24. But that's not the right answer, okay? So you need to be careful and make sure that you're using these lines like I do to make sure that MNO and BC are the ones that line up. So really what I'm asking is I'm saying, look, 14 gets multiplied by some scale factor K, and when it's done, it will equal the number 24. So what is that scale factor K? Well, just solve it. That's multiplication. How do you do multiplication? You divide. And you get K equals, let's reduce, 2 goes out of both of those, 12 on top, 7 on bottom, 12 sevenths. And we're done. 12 sevenths is our K. Now, the ratio of proportionality would be 7 to 12, but our scale factor is 12 sevenths. K equals 12 sevenths. Okay, next one. I'm going to have to erase some of this. I think I've kind of encroached here. Oh, and let me ask real quick. We were going to use this one to check. K is greater than 1. Is 12 divided by 7 bigger than 1? Well, put it in your calculator, and I believe it's 1.5. What is it? 5.4? What? 1.71? Okay. So 1.71. All right. So that is good. It is bigger. Oh, let's extend the page here. Okay, number 8H, find the value of X, Y, and Z. Now, this comes from chapter 9.1, I believe, and the geometric means. And this is a this is one where you're going to have to pretty much just memorize because it can get really tricky on trying to keep up with which one's the short, which one's the medium, which one's the long on these. And so generally, most teachers have you guys just do the geometric mean of the two. I prefer to do the similarity ratios, so I'm going to do the similarity ratios on this. Okay, so I've got the small, the medium, and then the large one is the largest triangle. Let us start with two things we can compare. It looks like I can compare and start with Y. Y is shared by both the small and the medium triangle. Now, in the medium triangle, here's the way I normally do this. I will go around and say, look, this is the short, this is the long, and this is the hypotenuse. Okay? This is obviously the hypotenuse. And because this is distorted, this is no longer a 90-degree angle in actuality, but it's supposed to be a 90-degree angle. What ends up happening is our 8 is actually our short side, and this is our long side. And one thing I told my students is you can never have one side that is both. You can't have short here. So that's how I knew that that had to be long, because it couldn't be hypotenuse, and it can't be short because it's already taken. And then over here, hypotenuse, short, and long. So setting this up, what I'm going to get is that in the small triangle to the medium triangle, I'm going to set up and I'm going to say, look, I know that the large side is 10. Oh, I'm sorry, that's the small triangle. the large side is y in the small triangle. The large side is 10 in the medium triangle. I know that the small side is 8 in the small triangle, and the small side is y in the medium triangle. Now what this ends up getting is whenever I cross multiply, I'm going to get y squared equals 8 times 10. And this is where your teacher told you that y is the geometric mean of these two. Okay, so it's going to be the square root of 80, which equals, well, that's going to be 4 times 20, which is 4 times 5. So that'll be the square root of 16 times 5. So that'll be 4 roots of 5. 4 roots of 5. Okay, and then you can do the same thing to find x, and I believe x is going to end up being, let me just erase all of this. So now if I go from the medium to the large, and I want to do the hypotenuse, okay? So the hypotenuse of the medium triangle is x. The hypotenuse of the large triangle is going to be 8 plus 10, okay? The hypotenuse, and then that's going to lead me to the long side in the medium triangle is 10, and the long side in the hypotenuse is going to be x. All right, cross multiplying, you're going to end up getting x squared equals 10 times 8 plus 10. Okay, and that is where your teacher told you that if you're going to do x, you're going to do this one times the sum of the two. So it's the geometric mean. And so you're going to get x equals 10 times 18 is going to be 180. So that's going to be 9 times 20, or 36 times 5. So 6 roots of 5. 6 roots of 5. Finally, z, you can do something very similar. You can say, look, z is going to end up being 8 times the sum of these two. So it's going to be 8 times 18, and then take the square root. So z equals the square root of 8 times 18. So that's going to leave me, well, that's going to be 9 times 4 times 4. So 2 times 2 times 3 is going to be 12, I believe. 12. I believe z is 12. I may be wrong. Okay, I've been known to be wrong. And so let's move on. Not my forte. I hate those questions, but we got to get them. So find the value of x if the trapezoids are similar. So we have to be careful not to just say, look, oh, x and 21 match up. No, they don't. Okay. You're going to have to use an assumption here that x is smaller than 16 just because the picture looks like it's smaller than 16. We don't know for sure. The picture may not be drawn to scale, but we have to make an assumption here that x is the small one, so that x matches with the 10, and the 16 then matches with the 21. Okay. If we take that assumption into play, then we can say, look, x is to 10 inches as 16 inches is to 21 inches, and inches are going to reduce and just multiply that direction, and you're going to get x equals 160 over 21 inches, which, could you reduce that for me, 160 over 21 in your calculator? Over 21, that's going to be about 7 something. Yep, inches. Okay. All right, so 8J, explain why it's possible to find the value of x below. Explain why it's possible. Okay. Think about side, angle, side, and side. and angle-angle theorems. Well, I'm going to tell you that if I was going to do this, that we can, because these are parallel lines, we can say that those are corresponding angles that are congruent, and they share an angle here. So our angle-angle theorem says that triangle 1 and the large triangle are similar. And since they're similar, then I can say that a proportion does exist where x is to 15 as 21 is to the sum of those two. And I can cross multiply and find out. And it looks like, let's see, 3 out of there, that's going to leave 7. 3 out of here is going to leave 9. 3 out of that, and 3 out of that's going to leave 5 and 3. So we're going to have 35 thirds, which is approximately, what, 11.67? And there were no units. Oh, and that answered 8K, so there we go. That's the only two I can do today, guys. Maybe I will do some in class tomorrow.